Hey everyone, welcome back to another update on the Spectrum Game Tool. Got a lot to cover today. It's been a bit longer again, unfortunately. Hopefully when you see what I've been working on, you'll understand why there's been a bit of a delay. Some significant changes underway under the hood. Hopefully again moving closer and closer to something that might warrant a closed alpha or early access type program in the not too distant future. First thing to cover off though, the name. I decided after putting it off for a long time, far too long really, that it was time to give it a name. The Spectrum Game Tool, or the unnamed Spectrum Game Tool, just didn't cut it anymore. So I spent a lot of time trying to come up with names, even employed ChatGPT to try and give me some hints and tips. It came up with some good names, but it seems that everything with retro or game or creator or forge or any variants on those type of words is either taken or just didn't feel right. And I didn't want to take any risks of getting into any legal issues, so reusing a name, even if it seemed like it was a completely different field, was a risk I didn't want to take. So I decided to take a different approach I took many years ago when I started the Axis project, which was my RenderMan renderer that I worked on for a long time, open source project. So I basically chose a name for that based on a few premises. One was it was misspelled intentionally, so that the chances of having a clash with existing names was limited. It did have some sort of reference to the nature of the project, but only minimal. So I followed that same route here with naming this project. I decided to go with something that was awkward spelling to try and reduce the risk of clashing with an existing project or product or company. So the name I've come up with, I also did want to make it a little bit sort of relevant, semi-relevant, not put a lot of effort into making it relevant, but one of the concepts that came to mind was the idea of an old drawing or art creation instruments, things that people would have used in the past as a hark back to the fact that this is targeting old technology. So the word, the sort of thing that I came up with in my mind was the idea of a quill pen, the feather pen that scribes used to use to write books with ink, and based on that, the idea of the quill, I've come up with the name Quill, spelled K-W-Y-L-L. So I've now managed to get the .com domain, so it was safe and secure. It's a fairly simple name, single syllable, so it's easy to remember. The spelling is off, which makes it simple to remain unique, but easy to remember. It's not particularly complex, it doesn't break too many rules, it's phonetically sound, and I like the name, I like the way it sounds, so that's what it's called now. I'm not suggesting for a second that that's the font that I'll be going with for a logo. I haven't put any work or effort into thinking about logos or fonts or anything at this point, but that's just the name. So, and I like that font, I thought it fitted the idea of a quill, so that's where we are. That's what it's called now, and that's what it will be called from here on in. Okay, with that simple thing out of the way, let's move on to what's actually happening in the product where it matters. So some of you will have seen the short teaser video that I posted earlier this week, just again as a way to fill the space, because I knew this was going to be a little bit longer, and had a few problems getting it to work as well as I wanted it to before I was ready to release this full video. So you'll have seen some of the things that's going to be demonstrated here, but I'll go into a lot more detail now about how it all works and what it means. So if I switch to the editor quickly, the first thing to cover is the tool chain. So one of the things that I was very concerned about approaching the idea of getting it into the hands of other people to test was the complexity of setting up the Z88DK compiler and toolchain, especially as I had to modify some of the components of that project in order to get it to work. I had to fix the sprite library and make a few other changes. And it's also a pretty monstrous project. It's got a lot of stuff in there that just isn't relevant to my particular use case. It covers a lot of different systems, which introduces a whole host of files and data and libraries and so on that just weren't appropriate. And I didn't really want to get into a situation where I was encouraging people to, or requiring people to go out and spend a lot of time either getting binary installs of the Z88DK as delivered by the project owners, or even worse, building it themselves in order to get the changes that I've had to make to the SP1 library. So I decided instead the best solution would be one that actually I got the idea of from Godot itself. So when you install Godot, anyone who's familiar with Godot will know that in order to actually export the project that you've created, you have to download a separate package which has the export templates for the various different platforms. So I thought maybe that approach would be better, which means I didn't have to package everything up into the main deliverable. It can be delivered separately. It means also that if I need to make changes to the compiler toolchain at any time, I can make changes just to that without having to release a new version of the tool itself if I'm in the middle of doing something to the tool that doesn't warrant a release at that point. Just makes it a lot simpler to keep the two separate. So with that in mind, what I've done is I've created a fork of the Z88DK project on GitHub, and I've included my small fixes and changes mainly to the sprite library, but also I've had to, in order to get the integration that I'm going to show you in a moment working, I've had to make a couple of small fixes to the tools themselves, because in certain circumstances they don't work well with spaces in the paths. So I had to fix a couple of bugs in there. So what it means is I now package up just the parts that we need in order to build a Spectrum game. Just the tools, just the header files, just the libraries that are required, nothing else. And if anything else comes along that I need as the harness and the engine aspect grows and changes, I'll include those in updates to the toolchain. So now when you go to the export, there's a few extra features in here. It's printing some stuff down here, so this is where output from the various stages will go. And you see at the moment it's saying it can't find a compiler, and the toolchain is showing as not installed. So all you need to do in that case is click this button here, and it'll go off to GitHub, where on my fork of the Z88 project I've got a package release as a zip with just the files in necessary. At the moment it's only for macOS, Apple Silicon, because that's what I'm testing with, but I'll be producing ones for Apple, Intel, Windows, and possibly Linux if I can work all the details out. But for now, all it does is it'll go up, it'll download very quickly the zip file and unzip it into your local system in the shared folder that Godot provides for projects. And because now the tool itself knows exactly where that tool chain is, the editor, the game editor knows where the tool chain is, it allows us to completely sidestep the phase of going out to a command line and typing make, which you'll have seen in all the other videos I've been doing up until now. So I won't build an empty project because it's pointless, but if I quickly load my standard test game, so just to show you it's the same as before, it's the same as everything else, all the rooms and so on. But now if I go to export and choose my export directory, or you'll notice you can't export at the moment. There's limitations on here. If you don't have a toolchain installed, it won't allow you to export, and if you haven't set where it's going to be built to, just a safety protection there. So now the export button is enabled because it's got a validly installed toolchain and we've got a place to send it. So I'll hit export, and you'll see it'll go through. This is the status bar here showing you the different stages of the export. The first stage at the moment is very quick, it'll go almost instantaneously, which is just preparing the data and exporting the header file that sits along the C file, the same thing it's always done in the past. But then it'll switch to a building phase, which is actually where it's calling out to the installed tool chain that we've just installed here, and performing the build, the compile, the C-compile, and creating the .tap file directly from within the tool. So there's no need to go out anymore. I will speed up past this because it's still slow. It's going to be as slow as it is because it's doing an optimized C-compile, and I'll be back in a moment. Okay, that's all done. We're back. So as you see, it now outputs all of the data that the compiler, all the messages that the compiler prints out to the standard output during its process. If you have any errors or any concerns, they'll be in here. It does output a lot of extra information. I might pare that down a little bit, but it's actually quite useful to see at the moment. But if it gets through to this final stage, the app make, that's basically packaging up the binary file that the compiler has generated into a .tap file that can be loaded into an emulator or put onto a real Spectrum with the right tools. So now that should have created it, and if we switch quickly to the emulator and load it in just to check. And everything's working as normal. So that makes the export process a little bit more streamlined. It's still not quick, but there's nothing we can do about that. That's the price you pay for something that compiles and optimizes as best as possible. It's actually compiling this down to a fairly small file at the moment. I'm sure there'll be lots more optimization I can do in the future, but for now it's doing a good job. So everything's working as normal. Move off to different screens. Nothing's changed there. So that's the export and the tool chain element covered off. If we switch back to the editor, I can start to show you some of the other new things. So I'll touch on the logic first. I've made a few changes in the logic. These came along as a result of the other major feature change that you'll have seen in the teaser if you've seen the teaser. But I noticed a few weaknesses in the logic that I wanted to address as part of this release as well. The main thing is this spawn down here. We always had the spawn before, which was for the bullets. So when you fire, it fires a bullet, and if you remember from the previous videos, it always fired off to the right, and that's because that's just how the bullet logic is set up, or it was always set up, just to move it 5 pixels to the right every frame. So now what I've introduced is a new variable on the bullet, which is the direction, -1 or 1, and then a little bit more logic in here, which just basically takes the speed as an integer constant, multiplies it by the direction, and then adds that to the x position. So if we set the direction variable on this object, we can choose which direction it shoots in. So then I needed a way of actually getting that information in there from the player. The player is the object that's responsible for creating the bullet and spawning it. And I always had this spawn ref output from the spawn object node, which is it's blue, you'll see, so it's a different type of data. This is the standard data, which is integers at the moment, but this is an object reference, and you'll notice that set variable and a number of other object related nodes have this ref input, which means they can be used not only to work on the object on which they are being created, so this is on the player. If that's disconnected, all of the logic in that node will apply to the player. But if you connect a valid reference variable in, then whatever is in here will happen to that object, not the object that the code is on. So basically what I can do here is I can say we've spawned the object, the code flow goes to this set variable, and we say I want to set the variable on the object that's been spawned, which is the new bullet. and then I can get the variable here, which is facing. I've introduced a new variable on the player, which is currently where it's facing. It's different to to the direction, because the direction it changes depending on what keys you're pressing. So if you look up here, direction is set to whatever the input of left and right is. So if left and right are not pressed, so if you're not touching any keys, then direction will be 0. And if you press fire then, and you were using the direction variable to set the direction of the bullet, it would just sit still. It will go nowhere. So I introduced basically a latching. So every time we change direction by changing the animation here, I now set the facing variable to the direction, and that just only stays. It only gets set if we have actually changed direction, because the integer compare here for 0, which means there's no horizontal movement, does nothing if it's 0. So if there is a change the animation to whatever animation is appropriate, and then set the facing variable. And you'll see this in a minute how that works. So now we're setting the bullet. We're setting the direction variable on the bullet to the facing variable on the player. So it'll always fire in the direction that the player is facing, whether he's moving or not. Now, one thing you'll notice is this is now text, whereas if you have a set variable up here, if we've got another set variable there, it's a drop down and lists all the objects, all the variables on this object. You can't do that in the case of an externally referenced object, because we don't know at compile time what this object is going to be necessarily. In this case we do, because we know it's a bullet there, but there are other places where, so for example, another use of the reference is in the collision detection in the move object. So if the move object node moves and detects a collision, it will provide through this link the object that you've collided with, and we don't know what that's going to be until runtime. You could be colliding with any type of object. So I took the decision at this point to say that if you're working with any of the object-based nodes and you're using an external reference, then we're not going to try and be clever about which variables are available. So you just have to type it in, and you have to be careful. So you look at here, find that one, and say, right, that's the one we want to put in there. And you have to specify the object type, and this is because otherwise, because you only know one object type has actually been hit, or this is being worked on at runtime, and C has no runtime type information, you have to explicitly state what type it is. So this will only do anything if this object coming down here is actually a bullet, and the same up here. It will only do any of this object variable code if it's a portal object. If it's not, it will just go through the invalid path and do nothing. So that's why change room only works when you walk into one of the portal objects. And if you disconnect this, you see it goes back to a drop down, and that's so you've got those two modes of operation depending on whether this is connected or not. So that gives a little bit more power in the logic, and you'll see in a minute how that works, hopefully, if everything goes according to plan. I think that's the main thing. I've changed the look of the logic a little bit. Every object type node has this reference now, so all of these animations and so on can all operate on other objects if you have a suitable reference available. And I'll be adding some nodes to get references to other types of objects in the room and things like that, to make that more powerful as we go on. Okay, that's that. And the final thing, probably the most important thing, the thing that took the most time certainly and dragged this release or this update out further than I'd hoped, is this new tab up here, the preview tab. So again, you'll have seen the first test of this on the teaser video. It only had limited functionality then. It had no collision detection. It could only do certain amount of the logic. Now it's fully functional. It's able to do to simulate all of the logic nodes that are available in the system at the moment. And the way it works is literally, if we go back to this, it's basically executing this logic tree in the Godot engine. So there's no export to code or anything like that, like there is when it goes out to C for the Spectrum. It's actually running this logic tree node by node, following the links down. So I had to implement that runtime logic for each node type, hence the reason it took a little bit longer. And then introduce things like comparable collision detection that matches the Spectrum engine, so that it does the same thing. It is not an emulator, stress that. It's absolutely not an emulator. It's not a Spectrum emulator at all. It won't do color clash. It probably won't do a lot of things. It's not even attempting to be performance comparative. It's just purely a way to test the game logic in the tool without having to keep exporting constantly, going through that compile time phase, just to check that some small changes you've made to the game logic will continue to work. So the way it works is you come in here, you've got these two buttons. Stop is obviously disabled because you're not started. New panel over here. This is very early at the moment. I basically put this in because I was having some trouble coding up some of the logic nodes for the simulator, and I wanted to see what was happening under the hood without having to go into the Godot's debugger all the time. So basically, when you run, everything runs as normal. The animations now run. All of this animation on the bubble runs, and it's all happening through the logic. It's running those logic graphs every frame on every object. And we've got collision detection with the background, and we've got collision detection with the objects, which you'll see in a moment. As you can see, no color clash, which is nice, but not particularly helpful. So just showing you what's going on over here. I explained before the idea of the facing and the DIR. So if you look at the DIR, that changes as I'm holding down a button, -1 to 1, left and right, but the facing latches on to the last direction you are facing. So if I'm facing to the left, it'll be -1. It will stay -1 until I change direction, then it will stay 1. And that allows me to do bullets that fire in both directions. So I'm just showing in here the top dynamic object, the first dynamic object in the list, so I can see what the direction variable was getting. What I plan to do over here is have a much more functional tree of objects, a tree view of objects in the scene, and you'll be able to open them up and look at the variables and position and various other things as you're running. So it's a lot more useful. But if I just walk off to the side here, see the collision with the portal objects works. The logic flows through, it moves to a new room. The color attributes apply properly. So this one was colored yellow and red. This one is always white and black in the game as well. And everything else works exactly as it should. So I'm sure this is going to be really helpful for those who are working on a game and thinking more about the logic of the game, the way the game plays, and the way that all the different elements of the game work. It's going to be a lot faster to turn around changes than having to go out to the Spectrum all the time, I hope. So I think that's it. I think when you stop, just go back. It doesn't change anything. It's not destructive in any way. So when the preview plays, it takes a copy of the current world, current game data, and works on that, and then wipes it out as soon as it stops. So you can do whatever you like in here, and it's not going to make any difference. Even if your logic is moving stuff around and changing things when the simulation stops, nothing in the world that you're editing, or the data file that you're editing, is affected. I think that's where we are. I think some useful things, and I think, as I say, we're getting a little bit closer to a state where I can get it in the hands of other people. I need to get a Windows toolchain built and a Mac Intel toolchain built. Those are the two easy ones. A Linux build might be a little bit more troublesome, but we'll look at that as and when. And please do come back for the next update. If you like what you're seeing, please leave a like, subscribe to be kept informed of what's going on, and don't forget to drop by the coffee site and see updates there. I'm trying to post more regular, smaller updates there during the week, even if I'm not able to do a video. So see you again soon.